Hi everyone, I am Aosiam and welcome to the Math Podcast, where today we will explain the probabilities of poker. But first of all, what is probability? Well, we will use dice to explain further. Well, first of all, this is Rui An, Joshua, and Asher.
Hi guys.
Hello.
Awesome. So let's start the basics. Probably is all about the likeliness of how something's about to happen. When you roll a dice, there are 6 sides, each with a different number from 1 to 6. Each side has an equal chance of landing up. Rian, can you explain more?
Sure, Joshua. Since there are 6 sides on the dice and each side is equally likely to come up, the probability of rolling any specific number, like a 3, is a 1 out of 6. And we write that as 1 over 6.
So if I roll these dice, I have a 1 out of 6 chance of rolling 1, and a 1 out of 6 chance of rolling 2, and so on and so forth.
Exactly, Asher. But what if we roll 2 dice? How do we figure out the probability of getting a specific combination? For example, a 1 on the first dice and a 2 on the second. Joshua, do you care to explain more?
Sure thing, Aosiam. When we roll 2 dice, we need to think about all the possible outcomes. For each roll of the first dice, there are 6 possible outcomes. And for each of those, there are 6 different possible outcomes for the second dice. So we have 6 times 6, which equals to 36. So 36 total possible outcomes.
And if we want to know the probability of rolling a 1 on the first dice and a 2 on the second dice, we have to think about how many of those 36 outcomes show that combination. Since each dice roll is independent, the probability of a 1 on the first dice is 1 over 6, and the probability of a 2 on the second dice is also 1 over 6. So we multiply those together, 1 over 6 times 1 over 6, which gives us 1 over 36.
Wow, that makes so much sense. So each specific combination of 2 numbers has a 1 out of 36 chance of happening.
Yes, that's right. Now let's talk about the probability tree. It's a great way to visualize all the possible outcomes. Imagine a tree where each branch splits into more branches. For example, when we roll 2 dice, we first start with a branch that splits out into 6 different branches, which represents the 6 different possibilities, which further splits into 36 branches for the second dice. Then each of the,
Exactly, Joshua. A probability tree helps us see all the possible outcomes and calculate probabilities more easily as we can visualize easier. Let's try a simple example. What if we want to find the probability of rolling a sum of 7 with 2 dice?
To do that, we list all the combinations that add up to 7. There are 1 and 6, 2 and 5, 3 and 4, 4 and 3, 5 and 2, and 6 and 1. That's 6 combinations out of the 36 possible outcomes.
So the probability of rolling a sum of 7 is 6 out of 36, which simplifies to 1 out of 6, 1 over 6.
that's right, Asha. Great job. And the cool thing is, once you understand these basics, you can start to understand how probability works in different situations.
Let's explore another interesting concept. Rolling more than 2 dice. What happens when we roll 3 dice? How do the probabilities change? Ryan, can you walk us through it?
Of course, Aosiam. When we roll 3 dice, things get a bit more complicated, but the principles are the same. For 3 dice, we have 6 outcomes for the first dice, 6 for the second, and also 6 for the third. So we have 6 times 6 times 6, or 216 possible outcomes.
Wow, that's a lot of possible outcomes. So how do we figure out the probability of getting a specific sum like that with 3 dices?
Great question, Astra. To find the probability of getting a sum of 10, we need to count all the combinations of the 3 numbers that can add up to 10. This is a bit tricky, so it's helpful to use a systematic approach or use a computer program to list all the possibilities. Once we have the list, we can count how many combinations are there that add up to 10 and divide the number by 216.
That's right, Joshua, and this is where probability trees or tables can really help. They help us visualize and organize the possible outcomes so we can easily count them.
Another interesting aspect to consider is the probability distribution. With 1 dice, each outcome is equally likely. But with 2 or more dice, some outcomes are more likely than others. For example, with 2 dice, a sum of 7 is the most likely because there are more combinations that add up to 7 than any other number.
So if you roll 2 dice, a sum of 7 is more likely than a sum of 2 and 12.
Yes, exactly. A sum of 2 can only happen if both of the dice show 1, and a sum of 12 can only happen if both of the dice show 6. But a sum of 7 can happen in many different ways, like 6 different ways. 1 plus 6, 2 plus 5, 3 plus 4, 4 plus 3, 5 plus 2, and 6 plus 1. That's why it's the most common sum when rolling 2 dice. Next, we move on to the next segment about poker.
So here is how poker is played.
A standard deck of cards consists of 52 playing cards divided into 4 suits: heart, diamonds, clubs, and spades. Each suit contains 13 cards, including cards ranked from 2 to 10, 3 face cards, jack, queen, king, and ace.
First of all, each player gets 2 cards. In this scenario, there are 4 players. These cards are your whole cards and they are private. Only you know what your whole cards are.
Next, 3 cards are revealed face up on the table. These are community cards that everyone can see. 2 more face cards will be revealed later, but only after a round of betting, depending on how confident each player is of their whole card's ability to form a strong hand with the community cards on the table. They bet a certain amount of money.
What do you mean by a strong hand?
Well, you win in poker by having the strongest combination of whole cards and community cards. So, what are the possible combinations? In sequence form, the weakest hand to the strongest, we have the
High card, when no other player has a better hand, so we see whose whole cards have the highest value. Single pair, where one of a player's whole cards have the same rank as a community card. 2 pair, where a player has 2 different pairs of cards formed from the combination of whole cards and community cards. 3 of a kind, where the player has 3 cards of the same rank formed from the combination of whole cards and community cards. Straight, which is a hand that consists of 5 consecutive cards in sequential order, regardless of suit, formed from a player's whole cards and a community cards combined.
Flush, which is a hand that consists of 5 cards of the same suit formed from a combination of a player's whole cards and the community card. Full house, which is a hand that consists of 3 of a kind and 1 pair being formed from the combination of players' whole cards and community cards. 4 of a kind, which is a hand that consists of 4 cards of the same rank, formed from the combination of players' whole cards and community cards. Straight flush, which is a hand that consists of 5 consecutive cards of the same suit. This can be achieved by combining a player's whole cards and the community cards. Finally, royal flush, which is the hand that consists of the ace, king, queen, jack, and 10 of the same suit formed with the player's whole cards and the community cards.
Now, after the betting, we see the next community card. Players then rethink their chances of winning and place their second bet. Lastly, the last community card is shown and all the players reveal their cards. Then the dealer sees who wins and awards that person all the money everyone bet on the table. In this situation, we can see that player 1 on the right has a single pair of 2s, player 2 has a single pair of jacks, player 3 has a single pair of 10s, and player 4 has a pair of kings. In this situation, since everyone has pairs, we see whose pair is composed of the highest ranked cards. Thus, player 4 wins, as he has a pair of kings, the strongest hand of the table, and is awarded the money.
Now, how does probability play into all of this?
Well, let's play a game of poker and show you. Welcome to our poker segment. Please begin.
Here are the community cards: King of Diamonds, Queen of Spades, and 10 of Diamonds. Let's look at each player's hand and calculate their probability of drawing a favorable card next.
Rayan has the Ace of Clubs and 4 of Hearts. A favorable card for Rayan would improve his hand to a straight. For a straight, Rayan would need a Jack. There are 41 cards left in the deck, as each of the 4 players are dealt 2 cards and there are 3 community cards. Counting the favorable cards, Jack of Diamonds, Clubs, and Hearts, total favorable cards is equivalent to 3, as Asher has been dealt the Jack of Spades. Therefore, the probability of getting a Jack will be 3 over 41, which results in 7.31%. But if he does not get a favorable card in the first draw, the chance that he will get it in the second draw will be 38 over 41 multiplied by 3 over 40, as there are 38 unfavorable cards, and the second draw will be drawing from a pile of 40 cards. Therefore, Rayan has a 14.26 chance of drawing a favorable card next.
Ao Xiang has the 3 of spades and 2 of spades. The favorable cards for Ao Xiang will be 2 spades. Counting the favorable card, there are 8 spades left in the deck of 41 cards. There is only one scenario in which Ao Xiang gets 2 spades. It's when the next 2 cards drawn are spades. The odds that the first card drawn is a spade is 8/41. In the event that the first card drawn is a spade, there will be 7 spades left in a deck of 40 cards, and the odds of drawing spades again would be 7/40. The odds of both of these things happening would be their individual odds multiplied together, which is 56/1640, which is a 3.4% chance.
Joshua currently has the 3 of diamonds and 4 of spades. A favorable card for Joshua would improve his hand to a flush would be 2 diamonds. Counting the favorable cards, there are 10 diamonds in a deck of 41 cards. There is only one scenario in which Joshua gets 2 diamonds. It's when the next 2 cards drawn are diamonds. The odds that the first card drawn in a diamond is 10/41. In the event that the first card drawn is a diamond, there will be 9 diamonds left in a deck of 40 cards, and the odds of drawing spades again will be 9/40. The odds of both of these things happening would be their individual odds multiplied together, which is 90/1640, which is also a 5.5% chance. Next, Asher has the Jack of Spades and 2 of Hearts. A favorable card for Asher would improve his hand to a straight. For a straight, Asher will need any of the 9 cards, or the Ace of Diamonds, Spades, and Hearts, as Ryan has been dealt the Ace of Clubs. Counting the favorable cards, there are 4 9s, 3 aces, which equates to 7 cards in a deck of 41 cards. Thus, the probability is 7/41, which can be expressed as 17.1%. But if he doesn't get a favorable card in the first draw, the chance that he gets it in the second draw will be 34/41 multiplied by 7/40, as there are 34 unfavorable cards, and the second draw will be drawing from a pile of 40 cards. Asher has a 31.61 chance of drawing a favorable card next. In conclusion, these probabilities help each player understand their chances of improving their hand with the next card. This is a practical example of how probability works in a real-life situation. Thanks for joining us, and happy playing!